across the vast ocean of stars in our galaxy, an ocean so immense it holds hundreds of billions of worlds. One question rises above all others. Are we truly alone? This isn't a science fiction daydream, nor Bir Merak Fusıltısı. It's a genuine scientific mystery, one that continues to challenge everything we think we know about life, intelligence, and our place in the universe. And today, we are venturing straight into that mystery. In previous journeys, we grappled with the famous Fermi paradox, an unsettling contradiction between the overwhelming likelihood of extraterrestrial civilizations and the deafening silence we've observed so far. But now we shift our lens. Instead of asking, who might be out there, we ask something even bolder. How far can we push the boundaries of human exploration to find them? We're stepping beyond theory and diving into the technologies and visionary ideas that could one day launch us from our tiny blue world to the distant stars. Picture it for a moment. Humans walking across the surface of an exoplanet light years away, becoming the very aliens another civilization might one day study. It's a thrilling idea, one that forces us to rethink our identity as a species and confront the staggering future that awaits us at the edge of interstellar travel. But before we leap too far from home, our search for life also leads us inward, to the planets and moons of our own solar system. Here, the goal isn't grand civilizations or advanced intelligence, but something far more humble and equally profound: traces of microbial life. Tiny organisms that, if discovered, would confirm that life can emerge more than once, even in our cosmic backyard. And if life can appear twice, who's to say how many times it might appear across the galaxy? Far out in the cold, shadowed realm of Jupiter, one moon has captured the imagination of scientists more than almost any other: Europa, a frozen world that may be hiding one of the most promising environments for life beyond Earth. At first glance, Europa looks unassuming, a smooth, pale sphere slightly smaller than our own moon, stretching about 3,100 kilometers across. Yet, beneath that deceptively still surface lies a secret that could redefine our understanding of biology. Beneath its fractured, ice-armored crust is thought to be a vast global ocean, an ocean that may hold twice as much water as all the seas on Earth combined. And where there is liquid water, the possibility of life becomes impossible to ignore. To uncover this hidden world, NASA is preparing the Europa Clipper mission, an ambitious expedition designed not to land, but to fly again and again past Europa, peeling back its mysteries layer by layer. Its goal is simple yet monumental: determine whether Europa's subsurface ocean could support life. The spacecraft will survey the moon's icy shell, probe its chemical makeup, map its geology, and search for water vapor plumes erupting from the cracks. If such plumes exist, they could allow us to sample material from the ocean below without ever touching the surface, a scientific shortcut that could change everything. But Europa is not a friendly place for explorers. The moon orbits deep within Jupiter's intense radiation belts, a region so hazardous that electronics weaken within hours, and an unprotected human wouldn't survive long enough to finish a sentence. Even the hardiest robotic lander would face a countdown measured in hours or days before radiation disables it. So for now, human boots on Europa's surface remain the stuff of distant dreams, not because of distance alone, but because the environment itself is lethally unforgiving. And that raises a difficult question. If reaching a potentially habitable moon in our own solar system is already this dangerous, how can humanity ever hope to explore the stars? Surprisingly, two bold ideas rise from this challenge. The first is the concept of the Generation Starship, a massive interstellar vessel designed to cruise between the stars at sublight speed. Passengers aboard such a craft
would live out their lives entirely during the voyage, knowing they would never see the destination world themselves. Instead, their children, grandchildren, or even distant descendants would be the ones to awaken under a new sun. It's a concept equal parts inspiring and unsettling. But there's a catch. If the journey lasts centuries, what happens back on Earth? Technology never stands still. Faster propulsion methods might be invented after the ship is already departed, turning the original mission into an obsolete relic drifting through the dark. This dilemma casts doubt on the practicality of generation ships altogether, which brings us to the second solution, one far more daring, and potentially the key to humanity's cosmic future.
As humanity pushes deeper into the cosmos, one challenge rises above all others: speed. To explore distant worlds, or to stand any chance of reaching another star, we must revolutionize how we move through space. And that transformation may already be beginning. NASA has partnered with Lockheed Martin to develop a next-generation nuclear-powered spacecraft, a leap far beyond our current chemical rockets. Instead of relying on traditional combustion, this system uses a compact nuclear fission reactor to superheat propellant, creating thrust far more efficiently. If it works as planned, a trip to Mars, currently a 7-month minimum, could be shortened to just 45 days, a breathtaking shift in what we consider possible. Early designs estimate that nuclear thermal propulsion could push a spacecraft to speeds around 22 kilometers per second. But theory doesn't stop there. Some advanced concepts propose magnetic nozzles that channel scorching plasma out of the engine, potentially reaching velocities near 55 kilometers per second, over 120,000 miles per hour. Impressive, but still nowhere near enough. Because even at that speed, the journey to our closest neighboring star system, Alpha Centauri, would take roughly 26,000 years. And that's the problem with deep space. Everything is unimaginably far away. So researchers began to think bigger, exploring propulsion ideas that border on the extreme. One such approach is nuclear pulse propulsion, essentially riding a controlled series of nuclear explosions to achieve extraordinary acceleration. In theory, a spacecraft using this method could reach 13,000 kilometers per second, about 4.5% the speed of light. That would shrink the Alpha Centauri voyage to around 100 years, placing interstellar travel within the lifespan of a single mission. But even this might not be the limit. Other visionary concepts suggest spacecraft could someday reach 10% the speed of light thanks to technologies like solar sails, vast reflective sheets harnessing photons for propulsion. Then there is one of the most ambitious ideas ever proposed: breakthrough Starshot. Starshot aims to build a fleet of ultralight nanoscale probes equipped with light sails. Using an array of powerful lasers on Earth, these tiny spacecraft could be accelerated to 20% the speed of light. At that velocity, they could reach the Alpha Centauri system in just 20 to 30 years, followed by about 4 years for their signals to travel back home. It would be humanity's first real attempt to touch another star. The mission's target is Proxima Centauri b, an Earth-sized world orbiting within its star's habitable zone. Its discovery electrified the scientific community, sparking hopes that liquid water, and perhaps life, might exist on its surface. Though the odds of discovering intelligent life on our very first interstellar destination are slim, it represents a monumental opportunity, a chance to examine a nearby potentially habitable planet up close. But our search doesn't stop there. Beyond Proxima b lies another world that has captured astronomers' attention: Gliese 667c. Located about 23.6 light-years from Earth,
This super-Earth could be reached in roughly 118 years with a craft traveling at 20% the speed of light. Larger than Earth, yet smaller than Neptune, it likely possesses a rocky surface and a thicker atmosphere, conditions that hint at a stable environment ripe for liquid water. And where water flows, life may follow. The planet's position within its star's habitable zone makes it one of the most compelling candidates in the search for extraterrestrial biology, and possibly, under the right circumstances, intelligent life. Worlds like Proxima b and Gliese 667c represent more than scientific curiosities. They are reminders that humanity's journey is just beginning. Our engines are getting faster, our ambitions are getting bolder, and with each new breakthrough, the stars drift a little closer.
Our voyage across the stars now brings us to one of the most captivating destinations in the search for extraterrestrial life, TRAPPIST-1e. Roughly 40 light-years from Earth, even a spacecraft traveling at 1/5 the speed of light, a speed far beyond anything we've achieved, would still require more than 2 centuries to arrive. But despite this staggering distance, TRAPPIST-1e remains one of the most promising alien worlds ever discovered. This planet orbits deep within the habitable zone of a faint, ultra-cool dwarf star. In that delicate band of cosmic real estate, temperatures may allow liquid water to pool on the surface, one of the most critical ingredients for life as we understand it. TRAPPIST-1e is part of an extraordinary 7-planet system, several of which may also contain water. But this one stands out, Earth-like in size, potentially mild in temperature, and stable enough to spark hope that biology, in some form, may have taken hold there. If life exists anywhere beyond our solar system, TRAPPIST-1e feels like one of the first places we should look. From here, our imagined starship thrusts onward toward a far more remote world, Kepler-186f. This planet lies almost 580 light-years away, nestled in the constellation Cygnus. It too sits in the habitable zone of its star, a steady and long-lived red dwarf that could provide billions of years of stable conditions. Kepler-186f is especially intriguing because of its similarity in size to Earth. Yet what truly captures the imagination is not the planet itself, but what its extreme distance implies. If an intelligent civilization on Kepler-186f possessed a powerful telescope capable of seeing Earth clearly, they would not be watching Earth as it appeared in the year 1444, a time before the age of exploration, before global maps, before the modern world had even begun. The light leaving Earth back then is only now reaching Kepler-186f. This mind-bending reality highlights just how vast space truly is. Even with our theoretical starship traveling at 20% of the speed of light, the journey would take 2,900 years, longer than all of recorded human history. But our journey doesn't stop there. Pushing farther into the cosmic ocean, we arrive at Kepler-22b, a world located an incredible 640 light-years from Earth. It circles comfortably within the habitable zone of its star, and its size, larger than Earth, suggests the possibility of a thick atmosphere, rolling oceans, or environments entirely unlike anything we've ever imagined. Kepler-22b has become a symbol of what might exist out there. Alien continents hidden beneath unfamiliar skies, ecosystems shaped by forces we've never encountered. The idea that such a world could harbor life sends our curiosity into overdrive. Yet distance remains our greatest adversary. Even at 20% the speed of light, reaching Kepler-22b would take 3,200 years. For perspective, that's longer than the span between ancient Mesopotamia and today.
we are left standing on the edge of possibility, staring into a universe filled with promising worlds, but separated from them by oceans of space so vast they defy comprehension. These extraordinary distances force us to dream beyond conventional engines. Concepts like the Alcubierre drive, which proposes bending space-time itself to achieve faster-than-light travel, remain speculative. Yet ideas like these keep human imagination alive. They are reminders that every breakthrough in science began as something that once felt impossible. And perhaps one day, the gap between these distant habitable worlds and our own pale blue dot will no longer feel unbridgeable.